Hazel. Hazel is still a thing. Now recently, I made a goodbye video, and understandably so, quite a few of you were concerned about Hazel's future. You know, because I'm sort of using Hazel to build the world's first game engine designed for robotics training, which by the way, is going well, and we are hiring. In fact, we've just set up an office here in Melbourne, and the team that we've built so far is amazing. Anyway, this video is getting a little derailed. The point is that Hazel, whilst my priorities have changed, Hazel is still Hazel, and I still would like to release it, and work has actually been happening, and that's sort of what this video is about. I'm going to show you something that I started probably late 2024 that was just finished recently, and that is Renderer 2025. Did I mention we're going to release this robotics engine to the public soon? So if we go to hazelengine.com and we click on Millinode board, all of this is still up, you know, because Hazel is still a thing, and we have this roadmap to release, then Renderer 2025 is over here, and it's in this Renderer 2025 branch. That's where it was. And the whole idea behind this was to basically go from using Vulkan exclusively, which is what was happening when I last wrote a version of the renderer in Hazel, and instead to switch to something called NVRHI, which is a rendering hardware interface, basically something that abstracts renderer backends. So all of the various graphics APIs like Vulkan, DirectX 11 and 12, all of that, it sort of abstracts it into a rendering hardware interface, as it's called, an RHI. I actually wanted to make a few videos about NVRHI specifically, maybe in some standalone projects as well, so it's not like in a big game engine and perhaps hard for you guys to follow, but something a bit more simple where we maybe build something using NVRHI that acts as like an example for some sort of graphics or rendering applications. Because I quite like NVRHI. Of course, it has its flaws. Everything has its flaws, but it's a really great starting point. And especially if you don't have the resources or the desire to go down the road of abstracting all of these graphics APIs, you know, yourself, but you still want support for them, or even if you just want a higher level way to write Vulkan code, you know, something that will help you out with automatic tracking of resource states and barrier placement, stuff like that, then NVRHI is quite a good choice. It's actively in development. You can see the last commit here. Well, I'm just looking here, but it was, 3 weeks ago. So that was ultimately Renderer 2025, and that was something that I wanted to implement into Hazel. Now, this is now done and merged back into dev, which is Hazel's main development branch. So that is pretty exciting because this was not an easy project, and I'll show you the actual code differences and some of the stuff that changed. It is more of a backend change. So it's not like, you know, hey, look at Hazel's rendering now. It looks completely different. It still looks more or less the same. It's a little bit more rock solid. Ironically, better supported across other GPU vendors like AMD, because AMD tends to be a bit more pedantic when it comes to like their drivers and how they execute code that you write. NVIDIA is much more forgiving. It will try and sort of save the situation, whereas AMD will be like, nah, bro, that's just wrong, so I'm going to crash. Or whatever you're rendering just isn't going to look very nice. So ironically, even though this is a library written by NVIDIA, it's doing stuff more properly, and so it works better across GPU vendors, which is a big win. Now, this isn't an NVRHI video, so I don't want to talk too much about it, but one common question that people have is, but NVIDIA made it. Doesn't that mean that it only supports NVIDIA GPUs? No, it is just an abstraction layer over existing graphics APIs like Vulkan, DirectX 11, and DirectX 12. Those APIs are clearly not NVIDIA specific rendering APIs. They themselves are an abstraction over, well, they're more of a specification, I guess, for different GPU manufacturers to create drivers for their specific hardware that map to functions that are in Vulkan, D3, D11, and 12. So yes, it is written by NVIDIA, but it works with Intel GPUs and AMD GPUs. Anything that supports Vulkan, D3, D11, D3, D12, NVRHI works with those. Now, some things that haven't been done in this list is mostly the shader pipeline. So even though this might give the impression of, well, Hazel now supports D3D11 and D3D12, that's not quite the case. 99% of our rendering code has now moved into a place that is in fact abstracted across those APIs. And again, this will be more clear once we dive into the code, but something like creating a vertex buffer now happens via NVRHI, which means that behind the scenes, it can happen in Vulkan, D3D11, or D3D12. However, a really, really big part to supporting different graphics APIs is shaders and the whole shader pipeline. You still need a system that NVRHI really has nothing to do with that lets you write a shader in preferably one shading language, whatever that might be. Could be GLSL, could be HLSL, could be your own language, which goes into those languages, could be something like Slang, Slang, whatever it might be. You probably want to write your shader in one language and then have it be compiled into something like SPIR-V. That will work for Vulkan and DirectX 12 soon. So here is a little article, which admittedly is a long time ago, but basically DirectX is adopting SPIR-V as the interchange format of the future. So once Shader Model 7 is released, which it isn't yet, DirectX 12 will accept shaders compiled to SPIR-V. Shader Model 7 does not currently have a specific official release date, but is expected to arrive alongside Microsoft Shift to SPIR-V. Yeah, that's the point. Thanks, AI summary. Basically, it's just currently in development. But anyway, that will make things easier when it actually comes out. But in the meantime, it means that whatever language you happen to go to, and it could even be to SPIR-V bytecode first, you are still going to have to compile shaders to DXBC if you want to support D3D11 or DXIL if you want to support D3D12. So there's still that whole situation that we in fact do not support. But then again, there's not a huge need to support DirectX 11 or 12. If there would be in the future, it's a lot easier now because again, all of our rendering is in fact going through NVRHI, which does have these three backends. It's just we'd have to adapt the shaders. Now, if we have a look at some of the work that has gone into Renderer 2025, which was the branch that you can see I have in fact merged. That was a while ago. That was like the 9th of January. So you can see it's been a while. There's been like lots of stuff that's gone into this. As always, you guys can get access to Hazel and this repository by going to patreon.com/thecherno. That helps support the development of Hazel. But yeah, it's been like a really long, I wonder if I can find the beginning. Okay, here it is. So this was on the 19th of May, 2025. So less than a year ago, to be fair. This is the work in progress initial commit, compiles. And you can see over here, by the way, this is the commit that actually adds NVRHI as a submodule. So yes, it has been less than a year. I honestly thought it would have been more than a year, but anyway, that is where it all began. If you're wondering what tool I'm using to look at all this, by the way, this is GitKraken, the sponsor of this video. GitKraken is a visual Git client that makes it easier for you to see what's actually going on in your Git repo. You know, like a UI for Git. It gives you a really clean and powerful view of commits, branches, merges, all of the important things. One of the things that I generally like about GitKraken is the visual commit graph. I've used Git for a while, but things can get pretty overwhelming if you're working on a large project and everyone has their own branch that they're working on, there are merges going on. Maybe some people aren't quite doing the right thing and they're sort of making these diamond merges. Anyway, I speak from experience. Take Hazel, for example. Like even in this project, which currently isn't being worked on by that many people, there's still so much going on and trying to deal with it via the command line is basically impossible. With GitKraken, I can easily see where things diverged, what branches people are working on, how the merges are looking, what gets rebased onto what, and more importantly, you can cache mistakes before you make them. Of course, navigating history is super nice. You can click through the commits, see all of the changes, filter what you're looking at, and just understand the whole workflow visually. It's definitely one of the biggest things for me personally that makes Git feel way more intuitive and actually makes software development just easier. So if you want to stop working blind in Git and just honestly have an easier workflow, then check out GitKraken using my link in the description below. It's free to try and you can get 50% off GitKraken Pro by using my referral link. Huge thank you to GitKraken for sponsoring this video. Okay, so much development later and we get to dev. So let me take you through some of the differences. Obviously, this is like a year of development and it is quite a big change, but I want to sort of show you the gist of what's going on. Okay, so here is Hazel running. It is basically the same. Oh, I didn't mention one of the biggest changes, and that is that we upgraded our ImGui version. So we were on like a 3-year-old version of Dear ImGui. Now this is like let's have a look quickly. 1.92.6 whip. So yeah, this is much more recent. And to be fair, that was a massive undertaking as well. I feel like that almost took as long as the rest of the renderer. That's not quite true. I'm exaggerating. But anyway, that was a huge task as well. So yeah, I mean, again, it looks basically the same. There's like performance improvements and some other improvements, but more or less it's the same thing. So to show you what's changed, let's have a look at what the architecture sort of used to be of the renderer and everything. So inside Hazel, over here, inside the main Hazel static library, we have a renderer directory that has basically everything to do with the renderer. So this is like Hazel's render API. This is the API that you're supposed to use whenever you do anything renderer related. So perhaps we should start like there. So the scene renderer is this class that basically takes in like a scene as an input and gives you an image. So it's like, here is my scene with all of the entities and everything that makes up this scene. I'd like you to give me back an image, which is a rendering of that scene. That's what the scene renderer does. So if we have a look at the main geometry pass, here it is, we have our geometry pass. You can see that it's not like calling Vulkan code or anything specific. It's calling renderer, begin render pass, renderer, render static mesh with material. So it's still fairly like high level. It's not like, you know, bind my pipeline, do this or that. It's still like, you know, render mesh with material. So that's like, I want to render this mesh, but I don't want to use its material. I want you to use the material that I'm providing as a parameter. The normal draw call is kind of renderer, render static mesh, and that takes in a command buffer, which is where you're writing those rendering commands into. That's like the context. It'll take in the pipeline and then apparently like some uniform buffer and storage buffer sets that apply to that draw. We got the actual materials being passed in here, transform buffer information, so we can get the transform from like a global buffer. And then if we're using instance rendering, what the instance count is. Now that theoretically then goes into whatever API you're using. So if you were using DirectX, this would do what it needs to do using DirectX API. And of course, a similar story with Vulkan. Now, Hazel has never supported DirectX, but we did used to support OpenGL and Vulkan. So in that case, we would have an OpenGL renderer kind of that does all of this stuff, and we would also have a Vulkan renderer that does the Vulkan stuff. And in fact, at the moment, if we look at what render static mesh does, you can see it goes to whatever our render API is, which in this case would just be Vulkan in this version of Hazel, and we have a Vulkan renderer.cpp which implements this render static mesh function. And you can see what that does, the actual Vulkan code, and it's submitting this to the render thread, to the render command queue, I should say, because the editor doesn't have a dedicated render thread. These commands are just deferred, but the runtime does have an actual render thread. Not sure why Visual Studio thinks these are all errors, but anyway, you can see it's a bunch of Vulkan code, and it, at the end of the day, is going to do the actual VK command draw indexed into the command buffer that we are passing in as context. So that's sort of how it works. So fundamentally, it's very simple. All of your resources have to be abstracted, so things like your materials, your pipeline, your vertex buffer and index buffer, all of that stuff has to be abstracted. So those resources that are used by the renderer, textures are another good example, they get abstracted into like a Vulkan specific version, a DirectX specific version, whatever else, and the main renderer does as well, because that's where you're going to be passing in all of those resources. Now, meshes don't have to be abstracted because meshes are just buffers with materials and metadata and stuff like that. So meshes are internally built from resources that are render API specific. And so that's it. As far as graphics API specific implementations, we have all of the resources and the renderer. That's it. And so if we have a look at vertex buffer, just as an example renderer resource, you can see first of all that it's a runtime decision which API we're currently using. There's no real reason for this. You typically wouldn't ever switch your render API at runtime. This does obviously enable you to pick a render API during startup, as opposed to if this was compile time, in which case obviously you would only be compiling a binary with one render API and you couldn't possibly use another one unless you then also compiled a version with that other one or with multiple or whatever else. But anyway, that's why ultimately it's a runtime switch, because we might want to conditionally select that on startup, as well as ship binaries that include multiple render APIs, and then the user can just decide. Now, none is useful, probably not in this version. In the net branch, which is where we implemented multiplayer, it is quite useful because none just means that we don't want any rendering. So this is basically a headless mode. In this case, it just returns null pointer. But anyway, if it's Vulkan, then we're going to return a new Vulkan vertex buffer, which is a specific implementation that does derive from vertex buffer. Vertex buffer, this is like the API agnostic thing. It doesn't even have any members or anything. It's just these like virtual functions and static create functions, which again are the things that actually map to the appropriate implementation. So it's kind of like an abstract class, like an interface. And then we will create like the Vulkan vertex buffer, and that will do all of the Vulkan specific stuff. So that's sort of the layer where we're at. We have all of this render API that I mentioned is graphics API agnostic. It will be implemented with a specific graphics API. And then under platform is where we have platform Vulkan, for example, and then here is all of the Vulkan specific stuff, which is basically the implementations of all of these abstract interfaces. Now, there is more stuff here that is Vulkan specific that doesn't really have a mapping here because we might want to do more Vulkan stuff. And of course, these aren't all necessarily classes, they're just files at the end of the day. And then we also have like the shader compiler and some other stuff here that is behind the scenes. Now, what's happened with NVRHI in the new renderer is that things have just shifted. The abstraction layer has sort of just shifted. So if we look at Hazel and we go to source Hazel, we have the renderer and we have all of these, basically the same render API. Like Hazel's render API hasn't really changed. But if we look at vertex buffer, look, it's actually an implemented class. It's not going into like Vulkan vertex buffer or anything. It's actually the implemented ref counted class. And then when we call create, it will return a new instance of a vertex buffer, which is the constructor that it will call over here. And then this, as you can see, is calling device create buffer. And the device, of course, is now an NVRHI device. So device create buffer, you can see that's where the implementations are. That could either be a D3D11 buffer, could be a D3D12 buffer, or it could be a Vulkan buffer. And so if we look at Vulkan buffer, for example, then you can see this is the stuff. I mean, here they're using vulkan.hpp, which is why it's not quite the C interface like the C++ wrapper. But this is the thing that at the end of the day is going to actually do context.device.createBuffer, which is this function over here inside Vulkan itself. So that's basically what's happened. It's like the abstraction point has shifted out of our territory and being owned and maintained by us to now being owned and maintained by NVIDIA, which is great. Less work for us to do unless things go wrong, which sometimes they do, unfortunately. But obviously, we have all of this NVRHI code in here. So if we have a look at the project structure, we have this NVRHI folder under dependencies, and we have the actual API over here, as well as the backends. So D3D11, D3D12, and Vulkan. And all of this code is obviously completely here. And in fact, we've even forked NVRHI. So if there is a necessity to build on this to fix things, which there has been so far, we can obviously do that right into our fork. And so we still sort of retain full control over this. That's another thing I know some people were concerned with. Like, are you just giving away like one of the core systems of your engine to a third party and now you're in their hands? Well, not really, because this is just all the code. And it's like, well, I'm either going to write something like this myself and then maintain it across all of the newer graphics API versions that come out, which is madness for like a small team with limited resources, or I just let NVIDIA do it, but obviously I've got everything here. So if I need to fix something, if there's like some bug that's stopping us from shipping on some driver, I need to patch it, whatever it might be, I can obviously still do that, because it's like, you have to view this as more of a starting point. I mean, it's more than a starting point because it's already written. So it's a bit more, I don't want to just brush it off as, oh, it's just a starting point. No, it's like, it's a functional library, but it's still just like a shortcut to me writing all of this stuff. And obviously I agree with the architecture. Some of the decisions they've made are not the best. There's actually something else by NVIDIA called NRI, which is, I don't know why they have both of them, but it's more of a low level bare bones thing. And it's much more, it seems to be much more performance oriented, whereas NVRHI is a bit more like, you know, it just allocates so much memory and it's just like all of this other stuff, which is not the best. But again, it's a starting point and it's not that hard for me to go in and like change stuff if I need to. So yeah, hopefully that gives you an overview of what has fundamentally changed. The benefit here as well is that NVRHI, for better or for worse, does provide lots of automatic like synchronization. That doesn't mean that it has a swap chain, because it doesn't even provide a swap chain. So Vulkan swap chain is a good example of, we still have a platform Vulkan directory. Even though we have NVRHI, you can see there's actually quite a lot of stuff in here. There's probably too much stuff in here, to be honest. I think some of the stuff can be deleted. The swap chain is an example of something that is not a leftover thing. Like, this still needs to exist. NVRHI doesn't provide you with a swap chain. So even though the swap chain is now using NVRHI, you still need to create and maintain this kind of stuff yourself. It's application specific, and NVRHI is not trying to be like this whole application thing. It's just supposed to be an abstraction layer. It's supposed to be an RHI. a rendering hardware interface. Thank you all for watching this video. If you did enjoy it, please don't forget to hit the like button. If you have follow-up questions, leave them in the comments. I'll have a read. If you want me to make some more rendering related videos, maybe use NVRHI to make a new little project or renderer, then also let me know in the comment section below. I've been meaning to sort of do something rendering related, so that might be good. As always, if you want to get access to Hazel and help support the project, go to patreon.com/thecherno. Link will be in the description below. You can have a look at all of this code and really do whatever you like with it. Don't forget to check out GitKraken, link will be in the description below, and I will see you guys next time. Goodbye.